Pong, the well-known arcade video game, released in 1972, has a major issue. It requires skill and 2 players, but I have neither of those. So today I'm going to create an AI that will play instead of me.
Before we get started, we need a few things. A powerful, top-of-the-line computer, like the one in the photo. Got it. Python. Yep, got a few of these in my backyard. And lastly, we need a Pong game. Thanks to my insane programming skills, this shouldn't take long.
Oh my god! Wow!
But it's a little plain for my liking. Let's make it livelier. Let's ask the almighty ChatGPT what the theme should be. Whoa, this is truly a life-changing piece of software. That's a wonderful idea.
Huh?
First, let's make a ball in Photoshop. Such an original and unique design. For pedals, I'm going to use this slime image, copy it, and simply put them next to each other.
You can see they have those tiny little hands, so I think it's only right to make them hold each other. The background will consist of a simple color gradient and a slime-shaped object on top. Next, we'll pick a better font. Better, but overall still too simple. Let's implement a few effects, like ball particles. They're basically just circles that decrease in size each frame and then disappear. Similarly, I'm going to add a pedal trail effect. The main difference, apart from the shape, is that instead of reducing the size, we reduce the opacity. To make the gameplay more interesting, I'll add a boost feature. The longer you move in one direction, the faster the pedal moves. When you stop or change direction, the pedal speed is reset to default. But of course, I wouldn't be considered a real gamer if I wouldn't blame someone else for my mistakes. So let's add an FPS counter. This way, if I miss the ball by a third of the screen, I can always blame 60 to 59 FPS drops. Finally, it's time to add some goofy sound effects. For the pedal bounce, I'm going to use these 4 sound effects. One will randomly be selected and played every time the ball bounces. For the top and bottom wall bounces, I plan to use this sound effect. But I don't think it fits well, so I decided to use the same 4 sound effects I did for pedal bounce. For the dead sound effect, I think it should be obvious what I was going to pick, because, as expected, I will use the sound effect. And voila! Pong game is complete.
Thanks for watching, and don't forget to
Hey, what about me?
Oh right, sorry about that. Remind me to edit this out.
It's time to show the AI this masterpiece.
We'll be using NEAT. It stands for Neural Evolution of Augmenting Topologies, and in my opinion, it's pretty neat. Traditionally, a neural network topology, which is the term for the entire structure of a neural network, is chosen by a human experimenter. However, with NEAT, the topology evolves and changes on its own, which can save you a lot of time. Before we can start the training, we need to yoink a config file and a few functions from the documentation, and we are ready to start. Each generation will consist of 50 genomes that will play with one another. The genomes each represent a unique neural network that will receive the following data as input: the y coordinates of the pedal they are controlling, y coordinates of the ball, and the horizontal distance between the pedal and the ball. To that information they'll respond with 3 outputs, whether they want to move the pedal up, move it down, or stay still. When one player fails to bounce the ball, we'll end the game and tell them how well they did by adjusting their fitness. In our case, their fitness will be based on the number of times they bounce the ball, as their goal is to survive as long as possible. Once all genomes of the first generation have completed their games, they will evolve, mutate, and produce new and more capable networks for the next generation. This process will repeat until we are satisfied with the result. Now, let's begin the training. This is the first generation of genomes. As you can see, these little creatures have absolutely no clue what's going on and how to act, just like me. Now, before my last two brain cells abandon me because of so many, I'll change the death sound effect to something more slimy. To get a better idea of what our little AI is thinking, I put 3 white dots on each paddle. These dots represent AI's decisions. Basically, every single frame, the AI gives us probabilities for all possible actions. Move up, move down, and stay still. The higher the probability, the bluer the dot. The paddle will move or stay still in the direction associated with the highest probability. Now, let's enjoy the show at 10 times the speed.
No one has ever done that!
Approximately 10 hours later.
Finally, after so many painful hours of training, all 1225 games in Generation 1 ended. Thanks to all the data the genomes have gathered, they will evolve, mutate, and produce new and much more capable networks for the second generation. So I thought?
Generation 4.
They're slowly starting to figure out their one and only goal in life.
Bouncing ball. Generation 7.
Is this one trying to press X to turn off the game?
Generation 12.
Hey, it seems like they have already surpassed me in skill. That's great!
Generation 23.
These two are surprisingly good.
Generation 41.
AI has found an exploit to survive without even moving. Now, I could properly fix the issue, or if the ball is near the border for too long, I can just launch it away at fast speed. Problem solved.
Generation 69.
Nice.
Generation 87.
They figured out that all they have to do is match Y coordinates of the ball. Now, you might be wondering,
Streaky, it must have taken tremendously long to run over 100,000 games.
well, it would. Approximately 120 hours if I did it this way. But luckily, there is an easy solution to drastically speed up the training process. The game is programmed in such a way that each frame, the ball and paddles move by a specific length. That means if we increase the number of frames per second, the gameplay itself will actually be sped up. Everything will move and happen faster. Currently it's limited to 60 frames per second, so let's remove the limit. That's great, my processor can handle 400 frames per second. That's almost 7 times faster than before, but this would still take too long. To solve this, I have 2 options. Option 1, I optimize the code.
Option 2, I optimize the code.
By disabling all effects and not rendering anything on the screen. This genius change will speed up the gameplay by 600 times as it runs on whooping 33,000 frames per second. I mean, honestly, who wants to watch AI play Pong when you can watch this epic black screen instead?
Generation 99.
Damn, they're good.
Generation 100.
We could train them further, but I think they're already invincible, so why don't we beat the world record of most ball bounces in Pong? Shall we? Enjoy!